an engineer who's analyzed, designed, tested, and helped troubleshoot ground source heat pumps along with other HVAC options. I can share success stories and challenges on a number of projects. Some of the questions that we hear are ground source heat pump systems an effective solution in the Northeast in this climate? Do they measure up to other system types? Are they effective part of a large-scale project solution to meet current sustainability goals as well as future objectives? To address these questions, I'm going to share some local ground source heat pump installations that have been installed for a decade or more. The approach used, the lessons we learned, and the owners learned that illustrate the benefits as well as the challenges and ways to help avoid those pitfalls and increase the odds of a successful installation and operation. We know that there are increasing regulations that focus on metrics often overlooked in the analysis of buildings. To date, Energy Code, US GBC, and other entities look more closely at dollars saved in percentage in keeping with ASHRAE 90.1, or an Energy Star, we looked at kBTUs per square foot. Today, metrics for CO2 and other greenhouse gas emissions are sharing attention. New York State has adopted the Clean Energy Standard, which is a mandate to get 50% of the electricity in the state from renewable sources by 2030. A 40% reduction in greenhouse gas emissions by 2030, as Jay mentioned, and 80% by 2050. So it's accelerating fairly quickly. In order to get the carbon savings, a drive to electrify systems and use large-scale renewables is in motion. The fact is, we are looking at a drive, and a very fast one, it was pointed out this morning, like a freight train, to get to net zero buildings and also carbon neutral. In this region, we know that with the March 15th gas moratorium, new firm gas service has been suspended for the blue area on the map. This change is a result of pipeline capacity limitations. Westchester is not the first, and there is no reason to believe that Lower Westchester is not the last area anticipated to be under the moratorium. Tompkins County was mentioned this morning. It's on a moratorium in New York State. The laws are changing as an environmental response, which makes using a more sustainable approach, such as ground source heat pumps, more attractive. But there are other advantages to using ground source heat pumps, and I'll highlight those benefits. This is a 28,000 square foot building, the Jacob Burns Media Center in Pleasantville, New York, that achieved LEED Gold certification. You can see the 13 kW PV solar array on the sawtooth monitors that they have a double duty and bring in effective daylighting. The ground source circulating pumps are indicated on the upper right of the slide, along with the manifold for the piping that goes out to the 30 wells for our loop field. This project was able to gain parking as well. Roof space for events due to the removal of a cooling tower air-cooled chiller. It also ensures that the neighbors weren't affected by HVAC condenser system noise. The geosystem size was determined based on available property space. Now the building envelope and other systems were modified to help reduce the load to meet that space that was available. And you can see the well field in the wrapping around the building. A supplemental heating system wasn't used in this to address some areas. We performed the commissioning for this 30,000 square foot gut renovation rehabilitation of a former school building built in the early 1900s for the New York State Office of Parks, Recreation, and Historic Preservation in Statsburg, New York. You can see the original school architecture in the photo. This project is the first public building in New York State to achieve LEED for new construction for platinum rating. NYSERDA participated in that both from energy through the new construction program and also incentives for the whole building. The building consists primarily of offices, public spaces, as well as the regional park police. The HVAC system includes 32 closed-loop geothermal wells. You can see in this photo, which is the opposite side of the building that now serves as the main entrance, we also performed the monitoring and verification services to review the energy performance and compare it to the original energy model. This effort served to prove that the actual energy performance met the model performance, and which was compared to energy savings for a code-compliant building at the time. This project is an example of significant improvements in envelope, which gave it the ability for simple heat pumps on a closed loop to address the colder northern climate. The building performed better than the energy model at the time of our M&V efforts. This project had a 10,000 square foot historic renovation and 35,000 square foot addition to the Poughkeepsie Public Library. It uses a closed loop system of wells, which some are under the building. They utilize water-to-water heat pumps serving air handling units throughout the building. We commissioned the systems, and about 10 years later, we returned to perform retro commissioning efforts. Again, northern climate relative to Westchester, and this time instead of unitary heat pumps as the previous example, water-to-water heat pumps provide hot and chilled water distribution. Again, this is another successful project up north, which performed, we did the commissioning for it. Again, another NYSERDA project. Actually, a lot of these are, at Trinity Pauling School. Bard College in Annandale, New York, comprised of over 150 buildings. They were an early adopter of geothermal heat exchange technology and have used on all new construction since the mid-1990s. We helped with the controls upgrade at this Frank Gehry designed Bard Fisher Center, Performing Arts, constructed about 15 years ago. The Bard building shown here also uses a closed-loop system, and again, water-to-water heat pumps. This is a 70,000 square foot science building that was opened in 2009. As I mentioned, the previous projects were all utilized closed-loop geothermal. As Jay mentioned, there's a lot of different systems, and there are a lot of other ground source options. We've seen mixed results with other projects that got away from the closed-loop systems, so I'm going to share a few of those examples as well. This project at Maple Grove Cemetery was not able to use a closed-loop system due to the subsurface conditions. It had a very sandy subsurface, and the test well was collapsing. It was decided to use an open well system. However, over time, due to significant iron content in the groundwater, the heat exchange became plugged despite numerous efforts over a long period of time to resolve the issue. Eventually, a cooling tower and supplemental boiler were added. This 75,000 square foot residential project in Westchester, New York, has standing column wells. We were asked to help with issues due to continuous failing well pumps. We found that the water levels weren't being maintained, and as a result, significant controls upgrades were used to help ensure that if a well level was too low, the system can compensate. The control system, and actually you can see a standing column well detail there. The control system regulating the level and temperature of the wells has increased the life of the well pumps. The building was finished in 2008. We did that controls upgrade in 2015, and with significant improvements to date. This 47,000 square foot library, again in Westchester, New York, came online around 07, 08, and utilized a standing column system as well. There were issues with the well production from the beginning, and presently only about 40% of the capacity can be realized. The library is working to leverage the wells as best possible. They don't really want to throw away their sustainable portion. But we're working to modify the controls to help reduce pump failures and implement measures to help with the lack of capacity. A question often asked is, what's the recommended approach to optimize systems? So those are some example projects. I want to talk about something a little bit different, and this maybe illustrates how we might be going forward with existing buildings as well as new. We're analyzing for the New York School Construction Authority a number of projects. In this particular project, it's a pilot analysis for working to meet high performance requirements. As illustrated this morning, New York City has a lot of different local laws that are driving performance, and consider retrofit to all electric to enable future renewable energy offsets. This basically shows that we've got, a traditional boiler system was there. We use a whole building energy model to analyze various metrics to get the energy performance to be what we would consider high performance. And I wanted to share this with you because New York City has developed a tool, an online tool, anybody can look at it. There's a lot of data in there to assess the feasibility, and it's really pre-feasibility of geothermal for each block and lot. Approximately 850,000 lots in all 5 boroughs are available to be checked. This tool was developed last year and has significant data to help pre-screen the sites for geothermal feasibility. It's in keeping with Local Law 6. In this slide, it can be seen that standing column and closed loop are considered pre-feasible. Therefore, per the law, further feasibility assessment would be needed. For this project, we looked at an air-cooled heat pump option, large scale, to generate chilled and hot water. That being said, there are large-scale water-cooled chiller heater options that could be ground-coupled as well, if that was the option that they decided to pursue. These particular ones can go up to 250 tons and can heat up to 150 degrees. For the existing building, this energy intensity baseline was 100 kBTUs per square foot. We were trying to get to below 15 kBTUs, and we were able to get down to 10 kBTUs. And for those interested in designing net zero, that's where you want to be. You want to be under 20, try to get to 15 or 10 kBTUs. That makes renewables more practical. The key to achieve these differences are excellent envelope, managing fan horsepower for fan distribution, often overlooked, high-performance lighting, plug loads, and heat recovery, and of course, high-efficiency heating and cooling. This project I did not work on, but I thought it was notable as it's a large-scale project in New York City on Staten Island. It's designed to be a net zero building. This school is approximately 68,000 square feet, has 2,000 PV panels, and approximately 80 closed-loop wells. Also mentioned this morning, but I did have this in my presentation, I wanted to note the Cornell Tech project that's also large-scale, has geothermal, and uses passive house techniques on large-scale buildings. And those passive house techniques are really the path to get you to where these systems can be right-sized and operate closer to where you can offset the energy with the renewables. Again, starting with the envelope is a critical step to feasibility and operation of a ground source heat pump system. When you consider the above reduction in energy, the reality of energy storage, and the large-scale renewables, such as this 2-megawatt solar project here in Westchester that we worked on for Swiss Re, it's clear that it's possible to move to a net zero approach, reduce reliance on fossil fuels, and still maintain comfort and performance expected. Using ground source heat pumps can be practical and will be an option to consider for current projects and future installations, in particular when gas is not available or when other options are desired. It's scalable and it's effective. You can also use the principles discussed in these projects mentioned to create district geoloop to serve multiple buildings, a full campus, or a municipality. Assessing the site, such as geotechnical and/or using a test well, and determining an approach is critical to be formed early in the project. Ensuring that the envelope and systems are designed to mitigate the size of the ground source system are important to reduce the incremental costs. Use energy modeling to help approximate performance and inform sizing of renewables and carbon offsets, and help obtain incentives should be considered normal and typical steps in the process. Ensure that your terminal units are adequately sized but not too large. Ensure that the mechanical space is in the right location and properly sized for maintenance can be 2 early design items that will affect long-term operation. Each building is custom and the solution should be custom. Ensuring that these steps are taken to mitigate incremental costs will help ensure the project economics are sound. The project should be commissioned, and owners should anticipate fine-tuning over time, just like any other system. Performing annual checkups on the systems and recommissioning will help the system life, space comfort, and realizing that the energy and resulting greenhouse gas savings. Thank you.